Good morning, everyone. What I'm going to talk about today is the structure-oriented diffusion with age preserving. We all know the diffusion process was firstly used to describe the heat conduction phenomena. It's a physical process which produces the difference appearing in a system to make the system to be equilibrious. Then the diffusion process was introduced into the image processing and proven to be a very effective way to remove noise and enhance image structural features. However, generally isotropic diffusion process will equilibrate all the high energy points with no energy points in the image to get black image, and it will remove the noise appearing in the image but also blurs the significant structural features and age of the image. In today's report, I will introduce an anisotropic and weight diffusion process to preserve the structures and ages of the image. For today's project, firstly, I will construct the structural tensor for each pixel in the image and estimate the orientation of the structural feature at each pixel. Then, we will get two eigenvectors corresponding to two eigenvalues. The eigenvector corresponding to the big eigenvalue is orthogonal to the structure. The eigenvector corresponding to the smaller eigenvalue will parallel to the structure. We will use the eigenvector corresponding to the smaller eigenvalue to control the diffusion process so that the diffusion process is parallel to the structure of the image, so that we can preserve and enhance the structure in the image. This technique has been widely used in fingerprint and seismic image processing. However, this cannot preserve age, so I compute the weight image indicating ages to preserve the age information in the picture. Then I will simulate the image with noise in MATLAB, and I will show you guys the results for the last part. For those two equations here, they're used to get the structure tensor and orientation information. The lambda v is the eigenvalue of the structure for the structure tensor T, and the uv are the corresponding eigenvalues. For the first picture here, it is eigenvector orthogonal to the structure, and the second one is parallel to the structure. Those two equations here are used to detect the age information. We can see the image in the right is the age information extracted from the noise image in the left. For those two equations, the first one is the oriented diffusion process. The second one is the oriented diffusion process with the age information. I is the image, D is the diffusion tensor, G is age information. Now, I will go to the MATLAB and show you guys. Okay, here we can see this is a function to get the structure tensor, and this is the function to get the age vector, and this one is the age information. Okay, just wait for a minute. Then we can get a very good result from my original picture. This is the original picture, and this is the one after the filtering, and this is the difference between the filtering picture and the original picture. And this one is the age information I am used to weight the diffusion process so that the age can be preserved. I also use this picture to get a very result. We can see this picture has linear structures and has a sharp edge along the dialogue. After the filtering, the structural features and the edge are perfectly preserved. This is the result I just showed you guys. Okay, that's all. Thank you.